Hello, and welcome to a My GCSE Science video about covalent bonding. Covalent bonding is one of the three main types of bond. You've got covalent, ionic, and metallic. So first of all, to define covalent bonding, a covalent bond is the electrostatic attraction between a shared pair of electrons and the positively charged nuclei of the atoms in the bond. Covalent bonding always occurs between two non-metal atoms. In covalent bonding, the thing that holds the atoms together in the bond is the attraction between the shared pair of electrons and each of the positively charged nuclei of the atoms in the bond. Importantly, this means that the bond, the attraction, is directional. It only exists between the atoms in the bond. This is one of the simplest covalent molecules you can draw. Two atoms of hydrogen with one proton and one electron joined together by a covalent bond. In order to simplify it even further, you can draw a covalent bond simply by drawing a single line between the two atoms that are joined together by the bond. Now, hydrogen is a relatively simple molecule, but what happens when we have a slightly more complex molecule, like ammonia, NH3? Well, you can see that there's one nitrogen atom and three hydrogen atoms in the molecule. So we can use the simple drawing with the N connected to the H's with single sticks to show covalent bonds, each stick showing a shared pair of electrons. Or we can use the dot and cross model to display the covalent bonds. So here we have the nitrogen as the central atom and the three hydrogens connected all around it. As we said, each stick represents a shared pair of electrons. So in each overlapping circle, each hydrogen atom has one electron. So we can draw one cross on each of the hydrogen atoms. Nitrogen is an atom that has 5 electrons on its outer shell. In each overlapping orbital, we show one electron from the nitrogen and one electron from the hydrogen, making a shared pair. So here we now have 3 shared pairs. But remember, nitrogen has 5 electrons on its outer shell, and so we have to show the extra 2 that are left over that aren't required in the bonding. You may remember in the ionic bonding video that we said that all atoms react so that they gain the same electron configuration as the nearest noble gas. So here we can see that nitrogen has 8 electrons in its outer shell now that it's shared 3 with hydrogen, and hydrogen now has 2 electrons in its outer shell, the same as the nearest noble gas, helium. The same dot and cross diagram can also be shown without showing the circles around it, only showing the electrons. Remember, it's important to show different symbols as dots and crosses for the different elements to be clear where the electrons have come from. Here, hopefully you can see that the nitrogen again has 8 electrons in its outer shell now, and the hydrogens each have 2, with 3 shared pairs of electrons, making the 3 covalent bonds, and 1 pair of electrons that isn't part of the bonding. Finally, there's one more way you might see this type of covalent molecule, shown by different colour circles representing each element, and stalks connecting the elements to each other. This is called a ball and stick diagram. However, it's important that you know that while these different ways of visualizing molecules are useful as models, they do have their limitations, and this is something you could be asked about in the exam. The displayed formula is useful as it shows each of the elements and each of the bonds clearly, and can also be used to show the two-dimensional shape of the molecule. However, it's limited as it doesn't show the three-dimensional shape of the molecule. The dot and cross diagram shows the two-dimensional shape of the molecules, and are also useful because they show all of the electrons in the outer shell of each element, even the ones not involved in bonding. This can be a useful way of checking that you've got the right number of bonds. However, as with the displayed formula, the dot and cross diagrams do not show the three-dimensional shape of the molecule. The ball and stick diagram, or even better, a ball and stick model made by plastic pieces called molymods, which you might have seen at school, is a great way of visualizing the molecule's three-dimensional shape. However, it is limited because the size of the atoms and the length of the bonds are not to scale and look much larger than they should be. All of these models also suggest that the electrons that make up the bonds don't move, which isn't the case. All of the electrons are moving all of the time. So while these models are all useful ways of visualizing molecules, do just keep in mind that they don't accurately represent the actual molecules, meaning that this isn't what they would look like if we could see them under a microscope. So let's have a look at some of the molecules that you might be expected to draw dot and cross diagrams for. First, we've got hydrogen, which we already saw an example of earlier. Two hydrogen atoms joined together by one shared pair of electrons. And remember that we can represent this covalent bond as a stick between the two hydrogen atoms, shown in pink. Now let's look at chlorine. Chlorine is also a molecule with two atoms of chlorine joined together, but this time each chlorine atom has 7 electrons in its outer shell. In the same way as hydrogen, each chlorine atom shares 1 electron each, making one shared pair of electrons, and therefore a single covalent bond between the two chlorine atoms. Here it is represented with the stick showing the covalent bond. Oxygen is another molecule which contains 2 atoms of the same element joined together. However, oxygen is in group 6, so in order to get to its nearest noble gas electron configuration, it needs 2 more electrons to fill its outer shell. So this time, instead of just making one bond, each oxygen atom needs to make 2 bonds. So in this case, with 2 oxygen atoms joined together, they both share 2 of their electrons with the other, making 2 shared pairs and therefore 2 covalent bonds. Now let's look at nitrogen. Nitrogen is again more complicated because it's in group 5. So it needs 3 extra electrons in order to get a full outer shell. Remember, the same electron configuration as the nearest noble gas. So each of the nitrogen atoms shares 3 electrons with the other one, making 3 shared pairs of electrons and therefore 3 covalent bonds. Remember, there aren't only 3 electrons on the outer shell of each nitrogen, there are 5, so don't forget to show the electrons that aren't involved in the bonding. Here is the triple bond formed between 2 nitrogen atoms, and just as before, you show each covalent bond as one stick, so we have 2 ends connected by 3 sticks. Now, all of these molecules on the right are formed from 2 different elements joined together. Let's look at the first one, known as hydrochloric acid, HCl. As before, the hydrogen has 1 electron in its outer shell, but the chlorine has 7 in its outer shell. Both need to share 1 electron so that they can get their full outer shell of electrons. So they share 1 electron with each other, forming 1 shared pair of electrons, 1 covalent bond. The next one is H2O, otherwise known as water. It has 1 oxygen atom and 2 hydrogen atoms. It might not be obvious at first which atoms are connected to each other, but oxygen can make 2 bonds because it needs 2 electrons to fill its outer shell, whereas hydrogen can only make 1 bond because it only needs 1 electron to fill its outer shell, each hydrogen sharing 1 electron with 1 electron from the oxygen. This now gives oxygen a full outer shell of 8, and each of the hydrogens have their full outer shell of 2. We're already familiar with ammonia, NH3, but we'll include it here anyway, just so you have a summary of all the molecules you need to know. Remember, nitrogen has 5 electrons in its outer shell. Each hydrogen has 1 electron in its outer shell, so the nitrogen shares 3 of its electrons with the 3 hydrogens, making a full outer shell on each of the atoms in the molecule. Remember, the name of this molecule is ammonia. It's got a special name that doesn't follow the normal rules, just like water and methane, all 3 of which you need to know for the exams. Here's a reminder of the displayed formula for ammonia. And now let's look at methane. CH4, meaning you've got 4 hydrogens attached to a carbon. Remember, each hydrogen can only make 1 bond, which means the carbon must be the central atom with 4 electrons on the carbon bonding to each of the hydrogens. So looking at the dot and cross diagram, we'll start with the carbon in the centre. Carbon's in group 4, so it has 4 electrons in its outer shell. Each of the hydrogens only has 1 electron, and it shares that electron with one of the carbons. The carbon's now surrounded by hydrogens, and by sharing 4 electrons of its own with 4 electrons from the hydrogens, it now has 8 electrons to complete its outer shell. As before, the hydrogen also has a full outer shell now. In the exam, you may be expected to draw the dot and cross diagrams for any one of these 8 molecules. Remember, it doesn't matter whether you draw the circles around the atoms or not, as long as you have the correct number of shared electrons, include the electrons that aren't involved in the bonding, and use different symbols to show electrons from different elements. A few key things to remember. Hydrogen only has 1 electron, so can only ever make 1 bond. Remember that covalent bonding happens only between non-metal and non-metal. They could be the same atom as each other, or they could involve different elements joined together by sharing electrons. It's important that you can identify how many electrons each element has to share, and if you're not sure about this, then check the group number on the periodic table, take the group number away from 8, and that will give you how many bonds the element forms. Elements in group 7 will form 1 covalent bond, elements in group 6 will form 2 bonds, and elements in group 5 will form 3 bonds, because they need 3 electrons to complete their outer shell. Finally, when you think you've finished, double check the number of electrons you've drawn, and make sure you haven't added any extras or missed any out. Each atom should now have a full outer shell of 8 electrons, including the ones it shared, other than hydrogen of course, which has a full outer shell when it has 2 electrons. This concludes the video on covalent bonding. Thank you for watching, and I hope you'll join me again soon on another My GCSE Science video.